I don't know where Hannah and Mally went though. So maybe I should invite them again? Maybe? Would that be annoying? Oops. Because it says that they came. Oh, there she is.
Okay, I'm here.
Hannah again. Hello. Okay. All right, let's get started. Oh, okay. Would you mind doing that, Rowena? I don't know. I'll do it.
Let me see if I can find it.
I can do it. I've got it right here.
Okay.
Do you want to read number 6?
Yes, I'll do number 6. Okay, so number 6. What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean? So the 3 that they talked about, the sigma must be known. Distribution, you need to have the QQ plot, or what was the other one? The CLT, can't remember the name. And then sample collected by simple random samples. Those are the 3 things.
Okay. I don't remember the QQ plot thing or whatever you were talking about, but I got the distribution of the sample mean is normally distributed. Is that the same thing that you're talking about?
That's the same thing, but he said that when I was watching the video, he said you can put in the QQ plot would be part of that. But that's a distribution.
Okay.
Number 2.
Okay. Sorry. My bad.
Okay. Did you get a hold of Hannah?
I texted her. She didn't respond yet. But I'll keep you guys posted.
Okay.
Okay, number 7. What is the point estimate for the population mean? And the point estimate is just the
sample mean.
Yes, which is 541, right?
Right.
Awesome. Is that what you got? Or Rowena, if there's anything that you got something different, just let us know. Number 8, it says create a 95% confidence interval for the population mean. Show all of your work below. So,
we take the 541, which is the sample mean from the number 7, and then you subtract 1.96 because when we were doing the part 1 earlier, the z-score was 1.96 for 95%.
95 percentile.
So, and we times that by 32 and divide that by your square root
sample mean.
Yeah, the sample mean 50. So the answer was 541, and then the first part you subtract, the second part you add the same thing, and you do the same equation, but you're adding it this time. So your answer should be 532.13 and 549.87.
Perfect.
Anybody else got?
Yes. I actually thought these ones were really easy. Did you?
Yeah, I really liked this. It was easier this time, but you know, before I can follow this.
Mm-hmm. Did you guys already do all of these ahead of time?
Yes.
Oh, okay. I did too. You did too, Rowena? Awesome. Okay. Do you guys have any questions on any of them, and we can just skip to lesson 11?
I don't have any problems. I did all of that. I did all of the you know, the only thing that I kind of had was number 12. How does the margin of error for 95% confidence interval that you computed in part 2 compared to the margin of error for the 90% confidence interval that you computed in part 4 or 5? Can't remember. But anyway, did you guys understand that? Did you figure that out? Because how do we get the 95% confidence interval is 8.87?
What I put was that the margin of error gets smaller as the level of confidence grows smaller. So, what?
Oh, okay.
But looking back on it, I did it 2 days ago, and I don't really remember how I got it.
Okay.
Let me look at the numbers that I wrote down for the last, for the ones that they're talking about. Hold on a second. Or Rowena, unless you can explain it off the top of your head. How about it?
Because that's the only thing. That's the only question I had was number 12. Because I didn't know how
I had a question on number 13. So hold on a second.
Okay.
So that's 95. What is it talking about part 4? When did we do a part 4?
I looked at that and I go, when did we do that? So I don't remember doing that at all. Rowena,
Oh,
do you
we
remember?
just made number 11. And it was just a typo kind of thing.
Could be.
Okay, because then confidence interval, that's what they're asking about, right? Yeah, the confidence interval for 95% is what we just said, 532.13, and on the upper or higher, I can't remember what it's called, 549.87. And then for 90%, it's 533.56 and 548.44. Hannah says she's coming. Okay. So the numbers are getting, okay, so the lower confidence interval from the 95th percentile compared to the 90 percent, sorry, I keep saying percentile, I mean percent. The 90% confidence interval for the lower is actually higher. And then what's it called? Is it called the upper? Is it called the lower?
The upper and lower.
Upper and lower. Okay, lower bound, upper bound. And then the upper bound for the 90% is actually lower. Does that make sense? I know I didn't explain the whole thing, but does that make sense so far?
Yeah, I was just, but still the confidence. When I checked my work, I looked at it and I didn't know how he got 8.87. Or the margin of error from a 90% confidence interval was 7.47. So I guess the higher the percentage, the higher the number, the lower percentage, the lower the number. I thought that was what he was talking about.
You said you didn't know how he got 8.87 as the margin of error?
Yes.
It's like how you figured out the answer to number 8. So the margin of error is like in the formula, in the confidence formula, it's the, are you looking at the formula where it says X bar minus? So once you figure out everything except X bar,
right,
all of that information right there makes the margin of error.
Oh, okay, I see.
So when you're doing that formula, you have basically your sample mean minus your margin of error. That's what that whole thing is.
I see. Okay.
So that's how you have.
Okay. That's all I wanted for number 12. So
Okay.
sample mean minus your margin of error.
Yes. 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 Okay, well, I had a quick question on number 13. In my notes, I see a sample size formula that says n minus, I don't remember all the names, but z with an a exponent, standard deviation over m, all in parentheses with the square root.
Yeah. The m is your margin of error.
Okay, that's what I was double checking because I was like,
so your margin of error is going to be 5.
Okay, got it.
So that's the formula.
So what is the answer? How many students?
So I got, the answer is 158. So you take n, you take 1.96, divide that by your 32 over 5, which is your margin of error. You square that by 2.
Oh, okay.
You square, and then your answer would be 158. You round it. You round it up. It's actually 157.3. 51936, but you round it up and you have to use 158.
Okay.
So the answer will be 158.
Awesome. Okay. All right. Hannah says she's coming. Do you guys just want to do 11 and then we'll go back and do the homework testy thingies when Hannah gets here?
Sure.
Or we can do it a different way. It doesn't matter. Nope.
Hang on. Yeah, whatever you, as soon as she gets on. Hello? Hello?
Okay. All right, so done with that one. There we go. Okay. All right. Were you guys good with lesson 11? For the part 1? Yes, maybe.
Just drop it off. You can put it in my mailbox because I'm online with my class. And if you can just drop it in the mailbox, I'd appreciate it. Then I'll get back with you. Okay, thanks. All right, bye-bye.
Okay.
Sorry, guys. I had a phone call from my second counselor for primary, and so.
Oh, that's good. I can't remember. Are you the president?
I'm primary president.
Nice.
Yeah. So.
Nice. I am Relief Society secretary, and I'm pretty sure I'm getting a promotion here.
Yes, I was Relief Society president at one time. Then I was gospel doctrine teacher for 10+ years.
Oh, I bet that was way better.
Anyway, so is Hannah on?
No, not yet. She said she was on her way a few minutes ago. I guess.
So, do you guys want to go to 11?
Yeah, Rowena is checking out part 1.
Okay.
I didn't really have a problem with anything in part 1, but then once I got to part 2, I had no idea what I was doing.
Crazy, and I never finished. I'm sorry, but I didn't get it done because I was just. I did most of it, but I didn't understand the last parts. But the p-value was hard for me. I tried to get on there and on the computer to work the p-value and try to download some things. But part 1 and lesson 11 list at least 3 characteristics of a student's t distribution. Do you guys want to do part 1, or you just want to skip to part 2?
If you have any questions on part 1, we can do that. I got part 1 for the most part, but then like I said, once I got to part 2, I had no idea what I was doing. But I did get number 1, but then after that, I had no idea what I was doing. Because once it starts talking about the degrees of freedom and stuff, I don't know what's going on.
Yeah, it's the T distribution and the degrees of freedom that I had a hard time with. So you got the formula on number 5. Conducting a hypothesis test for a single mean with sigma unknown. Did you get that?
Say what? Sorry.
The formula, number 5.
What is formula? What is the formula?
The formula is T.
English editing in this stuff.
T equals X bar minus the mu.
Yes, over S divided by the root of the sample mean, or sample size.
Yes. So when I plug some of my numbers in for these equations, I had a hard time getting it. I was trying to get it over. I had to do it several times before I could get the right answer. And that's using the same formula and then plugging in the right numbers. But I don't know. Maybe it's a calculator. I don't know. Maybe.
Oh, Hannah.
Hi, Hannah. Okay.
Can you hear us, Hannah?
Yes. Sorry I was late. I was playing Jeopardy with old people.
Cool.
Okay, Hannah, we already went over lesson 10. Do you want us to go over it again with you? We went...
Just the prep work, or did you do the quiz itself?
No, we did the quiz. We just did the prep work.
Okay. No. I did the prep work. It's okay.
That one was way easy compared to us.
It was much easier for lesson 10 than it was lesson 11, or any lesson. So what do you guys want to do? Do you want to do the quiz on that, or just go on with lesson 11?
I think it'd be easy. I know I just got here, but I think it'd be easier if we just did the quiz and then went on.
I'm fine with that. I have to leave in like a half an hour, so if we can just do 11, actually, so then I can ask questions and kind of figure out what I'm doing, and then I'll just do the lesson 10 quiz on my own. Does that make sense?
Yeah.
Okay.
So 11.
So let's do 11.
So we'll do 11 prep work and quiz, and then you'll be gone?
Yeah.
I'll probably be gone before we're just...
Or do you want to just do 11 quiz?
Say what?
Jonathan Shelby said, well, let's go over lesson 11, And then she has to go, and she said she'll do the quiz by herself, but we can do the quiz together as a group.
Right.
Oh, Shelby, you won't be able to post this then?
Oh, you're right.
You're leaving.
Okay, I'll figure it out. I'll figure it out in the next half hour.
Okay, so let's just go on. Let's start part 2. Did you guys get part 1 of lesson 11?
Hold on. It's not letting me look at it. What the heck? Oh gosh.
You want to go part 2 of lesson 11?
Yeah. I'm still trying to pull it up. Sorry.
Shelby, did you have any problems with part 1, lesson 11?
No.
Okay, this is part 2. So, do you want me to read part 2?
Yes, please. Sorry, I'm just trying to figure out how to get out of my visits here.
Okay, so let me read part 2, but let me go to part number 7 first. So it says, go to part 2, using your calculator or SPSS or Excel, compare the sample mean and sample standard deviation for the 15 pieces of data you see in part 2, and write your numbers here. So if you go to part 2, it has all the numbers written out. You add all those numbers, and then you divide it by 15, and my answer was 46.73.
Sorry, for what number?
So we're doing part 2, and the list of numbers that you have there's 15 of them.
Yes.
It says a study by National Association of Realtors reported in 2004 that second home buy or sales accounted for more than a third of residential real estate transactions. This is a problem that we did before. I think one of the first, or maybe second or third things that we talked about in one of our lessons. It says, according to the report, the average age of person buying a second home as an investment rental property was 47 years. A real estate agent wants to estimate the average age of those buying investment properties in this area. He randomly selected 15 of his clients who purchased an investment property and obtains the data shown. So he's showing the data right here. There's 15 of them. You add it all up, and then you divide it by 15. And my answer is 46.73. Did you guys get the same thing?
Oh, yeah, sorry. It just didn't have an actual question in it, so I didn't ever put an answer. So that's why I was confused.
Well, in number 7 above, number 7, it says to use your SPSS or a calculator or Excel, and then compute the sample standard deviation for 15 pieces of data.
Oh, okay.
And so that's in part 2. That's what they wanted us to do. So that was the total, 46.73. Anybody else have anything else to add to that? I think
that's what I got.
What?
That's what I got.
Okay.
Oops. Okay. And then for number 1, it says, what are the requirements for creating a 95% confidence t-interval? And I have that it has to be a random sample from a population, and that the point whatever it's called.
X-bar?
Yeah. What's that called? Like, what is it actually? Is it? It's not the. Is it the sample mean? No. What is the X bars? Whatever they are, they have to be normally distributed.
Right. What was your third one? Was it the? It has to be known.
I just have 2 actually. And the answer key actually only has 2, I'm pretty sure.
Okay, I had the first 2. the simple random sample from the population. So those are the two I had, but I didn't know if we needed it didn't ask. It didn't say. I just thought maybe there was a third one too.
No, the answer key just has those two.
Okay. Rowena, are we good? Are you doing okay? Okay. How about you, Hannah?
Yeah, I'm good.
Okay, so number 2, it says, with the data above, create a 95% confidence interval to estimate the mean age of all clients who buy an investment property. Input the numbers you computed in number 7 of part 1 into the confidence interval formula. Show your work below. The t-score for a 95% confidence interval for the t-distribution with 14 degrees of freedom is 2.1448. Make sure you do not overrun while making your calculations. So, create a 95% confidence interval to estimate the mean age.
95%. What was that? 95 was 1.96.
Yes.
The above did create 95%.
So do we do the X bar plus or minus the critical value?
You minus, subtract that.
It's plus or minus.
Yeah.
Times the sample standard deviation over the square root of the sample size? Is it that formula?
I thought it was just the m equals, or is plus or minus, blah, blah, blah. Hold on.
No, it's because they're asking for the t-score, so it's going to be t equals what formula that we had. Because it says the t-score for a 95% confidence interval from the t-distribution with 14 degrees of freedom
is 2.111448.
So it's 2.114.
Create a 95% confidence interval. So that would be like 2 standard deviations away.
So you subtract that 1.96 and times.
No, I think you just, hold on. You take the, is this for the sample mean for that one?
This is for number 2.
Yeah.
Okay.
They're saying with the data above, so it's the sample data?
Yeah, I believe so.
Okay. So let's do calculator.
Because it says take the numbers from number 7.
Okay, so plus
The t-score.
Oh, okay. Do that problem.
So don't we take the 46.73 and we just take the 2.1448? Don't we take that and subtract it from it twice and add it to it twice? Because the 95% would be 2 sample standard deviations away.
Why do we do it like that?
Oh, Rowena says.
Okay, this is what I did. Okay, what Rowena said. I took the 46.73 and subtract 2.1448, and I times that by 8.83, and did the square root of 15.
What?
Rowena? Okay, she said do the sample standard deviation, square root of sample size, then multiply that by 2.1448.
So what is the 2.441 or 2.
That's the 14 degrees of freedom. It's a 2.1448 in number 2. You see that?
Mm-hmm. Okay, so sorry, what is the sample standard deviation? Where do we find that?
8.83.
Where did you find that, though?
How did I do that?
Is that from the last, or from number 7, and I'm just not looking at it?
By using SPSS or calculator.
When we did the sample mean or whatever, right, Rowena?
Yeah, when we take those numbers, those 15 numbers that we had in that part 2.
Okay. Yeah. Okay. So it's 8.83 divided by the square root of 15,
square root of 15.
Okay.
In the answers, I think the 2 answers you should have is 41.8 for the first one. Did you guys get that?
Yeah.
And 51.6 for the second answer.
Because you subtract.
Because you subtract the first one, then you add the second part.
8, 8, 9. That makes sense.
Does it make sense? Okay.
Yeah.
Okay, so tell me what it is again. Sorry, guys.
The answer for number 3, the answer for number 2 is 41.8. That's the first answer, and then the second one is 51.6.
Okay, got it. Okay, number 3. It says now create a 99% confidence interval to estimate the mean age of all the clients who built an investment property. Follow the same rounding rules as above. The t-score for the 99% confidence interval for the t-distribution with 14 degrees of freedom is 2.9768.
So that's the same thing with a different t-score.
Right. Right, 46.73 and subtract 2.9768. Times that by 8.83 and square root of 15.
Okay, sorry, did you guys already figure it out?
Yeah, you do the same thing except for you use a different t-score.
Okay.
You use 2.9768.
And I got 6.7867.
What was your answer for that?
6.7867. But then you subtract it from the 46.73.
I got 39.9.
Yeah, hold on. Yeah, that's what I got.
Okay.
39.9?
Yes, 39.9 for the first one that we subtract. And then the second part is 53.5 because you add.
Yeah. That's what I got.
So all we're changing is the 2.9768, the t-score.
Okay. And the upper, is that what it's called? Is the upper in this one too? The upper and the lower, or is that just?
No. Does it say?
Open to capture. What is that?
Ooh, I'm taking pictures, sorry.
Oh.
I have a collage due for my humanities class, and I want to include my homework in it.
Oh, okay. Humanities class.
So you're going to be in my project, guys. You're welcome.
Thank you for asking.
Thank you.
My picture. That's cool.
Okay, so on B, so we already figured out 8, right? 4A. Correct?
Sorry, so the other one was 44 point what? It was 39.9, and what was the other one?
It was
53.5.
53.5. Yeah.
Sorry, I can't hear.
53.5.
Okay, sorry. I've got my kids yelling in the background.
It's okay.
All right.
Okay. Number 4. Okay, now using the software, compute these numbers. A, the 95% or percent confidence interval using the data above.
Didn't we just do that?
No, we just did that. Why do we do it again?
Because we just have to use SPSS doing it.
Yeah, and B, you're going to get the same thing for B.
Okay, cool.
Okay. Number 5. Are we ready to move on? Or let's see what Marina says.
It's the same thing.
Okay. It's the same.
Yeah, we're good.
Okay. Number 5, how does the margin of error of the 95% confidence interval compare to the 99% confidence interval? Let's see. So the margin of error.
I'll just put margin of error for the confidence interval is 99% is bigger compared to 95 and 97%
So like,
smaller.
yeah, so 95 would have a large margin for error, and a 99 would have larger.
Right, for the confidence level.
Okay, sorry, you guys go ahead without me. I gotta get something out of my head.
Okay. So number 6, rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average age of 47. So use the 0.05 as your level of significance. Follow the following sequence of steps. Fill in your answers at each step and show all your work. So A, state the null and alternative hypothesis. So the null is 47, and the alternative hypothesis is not equal to is 47. So it's different from the national average.
Yeah.
What do you think?
Yes, agreed.
Okay, sorry guys. I feel like a dead weight here.
No, that's okay.
Number 6.
So we did number 6, and we just did A, state the null and alternative hypothesis. So it's the null hypothesis is 47. The alternative hypothesis is not equal to, so you have to do that not equal sign to 47. Not equal to 47. So the difference from the national, it's different from the national average. Okay, B, are we ready to go on?
Yes.
Okay, B, compute the test statistics. First compute it using the formula and showing your work below. Then check the test statistics by inputting the data into the software. So the equation is T equals X bar minus mu over S square root of n.
Divided by the square root of n.
Divided by the square root of n. So I have T equals 46.73. Subtract that by 47. Yes. Divided by 8.83.
Okay.
That's 15.
Let me do that really quick. So
I can't hear you.
Rowena, what did you get for that? I got 0.118.
Oops. Do 8, and so you go 46.73 minus 47. Oops. I meant 46.73 minus 47 divided by 2.28.
So did you guys get that formula, Shelby?
Yes.
I got 0.118.
Yeah.
Okay.
Did everybody get the same?
Yes. This
Oh,
is
yeah.
for B, right?
For B.
Okay. Yes.
Okay, C, state the degrees of freedom.
Isn't that just...
N minus 1, right?
Hmm?
I don't know. That's what I have in my notes. It says determine the degrees of freedom. N minus 1. Is that totally wrong?
Okay, Rowena, you put 15 minus 1.
What? Did I get it right?
Yeah.
What? Cool. Okay, so it's 14. Right?
Yes.
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 And N is the sample size, right? Yes. Okay. So I
Yes.
answered that.
Yes.
All right. Cool.
Okay, D, sketch the T distribution and shade the area which represents the p-value, which I did not do here. So sorry, guys.
I didn't
I
sketch
think
it.
you have to get on the software.
Oh.
Okay, my SPSS works, but I can't say I know how to do this. So.
I don't know how to do the p-value, guys.
It's a bell curve with like the two sides. Oh, Rowena says it's just a bell curve with the two tails shaded, I think.
Okay.
So it's just.
So is that what we're writing, and then that's good?
What do we do? Okay.
Well, yeah. Sketch it.
Oh, I'm on my computer.
So for this one, wouldn't it just be like a little bell curve with the lines and stuff? And so since it's negative 0.0118, it would be shaded to the left, and that's it, right?
This is for D?
Yeah. So like that's my little baby bell curve. And I shaded it to the left.
You just shaded the little part, right? Just
Yeah.
the tail?
Yeah, because it's negative.
Good.
Right?
Okay. Okay, everybody ready? E, use your software to complete the p-value. Who's got their software up?
I do, but I don't know how to compute the p-value. Or compute.
Hannah, do you know how to work the p-value on there? Because I don't.
Let me see if it will work on mine. Let me pull it up.
What's gross, Rowena?
This stuff is gross.
This math thing, yep.
This math. Okay, quantitative. Descriptive. And let's go take all of. Where is it? Not what I was looking for. Are we still using the sample thing?
It's fine.
Are we still using like the sample of 15?
I think so, yeah.
Okay. Okie dokie, let me take these numbers here. No, all of them. And go delete all these numbers. Stop these numbers. Oh, that did not like. They did not like me doing that. So I'm gonna have to do this the long way. Hold on. 27, 49, 56. And then 45, 49, 35. And then 55, 50.
Finding the p-value, isn't it just a one sample t-test?
I don't know. It could be. Hang on.
Okay. Let's go descriptive statistics.
What is the test value?
Wouldn't the test value be 15? No, wait a minute. Hannah, what's the test value?
Hold on. Let me look at my notes.
I don't have it anywhere in my notes. Does it have anything to do with the margin of error?
Perhaps.
Oh, no, it says add the null hypothesis to the test value. So if our null is, what is our null again? 47?
Yeah.
So that's what
That's the test value?
That's what my notes say. So what are we trying to figure out again? The p-value.
Do you go to analysis and down to descriptive or compare means?
Yeah, I did it right now. I just don't know.
Go to explore.
Which one represents the p-value? Is it DF? Is that what that is?
That's the other thing.
No, DF is the freedom.
The degrees of freedom.
Degrees of freedom.
Well, this is what I got.
What do you have? What'd you get?
I just put it.
Okay.
Next.
Does that have it in there? I don't know how to read this.
One sample test value is 47.
That looked right.
Let me show it correctly. Hold on.
Degrees of freedom.
Here. Don't read that one.
Variance.
Oh, well, that's the same. Never mind. Sorry.
Okay.
Yeah, I don't know. Okay, so it says in my one sample test, my test value is 47. T is negative 0.117. What is T? Like the T distribution, is that what it's? I don't know.
That's what it is.
Okay, and DF is degrees of freedom.
Right.
Two-tailed is 9.09, the mean difference. And then there's the confidence interval lower and upper, but it doesn't tell me.
You know, I was looking at our text that we're supposed to read in the thing that they put. They said to find the p-value and compare it to the level of significance. It's totally different. I don't understand how to do that because it's a p-value equals 1.2723 times 10 to the power of 8. You understand that? Anybody?
Say that one more time.
It's in our text, lesson 11 or lesson 10. And it gives you the p-value. But it has like, the p-value is equal 1.2723 times 10 to the negative power of 8. But it says that the
Where do you
software
see
is
that?
with the E on it.
That stuff looks...
I know, p-value is confusing. Let's just go with that.
Oh, that's because. Oh, nope.
Oh, I got excited. Okay, so I looked it up online, and this is something that it says. It says a p-value is computed from the t ratio and the numbers of degrees of freedom, which equals the sample size minus 1.
So
it's the t ratio. That's not. I don't think that.
What's the?
Yeah, that doesn't make any sense.
I'm on my meeting phone. Okay, love you. I'll talk to you later. So let's look at D. Because D says sketch the t distribution and shade the area which represents the p-value. So if t equals,
yes.
is it 0.118?
Yeah. Can't we just go to the? No, that would be the T. So can't we go to the? Nope, that's not the same thing. Never mind.
Okay, guys, I'm gonna mute myself really fast because I. Oh. So, never mind.
Okay.
I was gonna watch a YouTube video on how to do it, but apparently my flash is out of date. But I could look at it on here.
Area to the left. What test statistics? If the test statistics on the left, what's the shoulder to the right? If it's on the left.
Example T and histogram. Is that what we're looking for?
Maybe.
I'm doing a dedicated video on the p-value is something, hypothesis test, that confuses lots and lots of students. If you're watching my video and you're at first you're puzzled about this p-value, don't worry, you join a big band question.
Okay. So I did.
Rowena says the p-value is the area to the left of the test statistic if the test statistic is on the left, and what's shaded to the right if it's on the right. So wouldn't it just be the negative 0.118? Do we have to do something with that? Probably have to do something because that's the t.
Mm-hmm.
I think that's something like students confuses because it's the way that they taught in university or
Can't
college.
we use the normal probability applet because that's the
Let's try that.
bell
See
shape?
what the area is, and we'll compute that.
By statistician, we
We'll
just
use the same formula that we used in in B.
don't have to use it. Okay, so the definition usually goes along the lines of something like
What's the p-value?
it's level up to check the null, or its probability at which you can see something as extreme, or more extreme than given that the null is true. That second definition is one that many psychologists usually take back to me and then don't know what you just said. So if that's you, don't worry. This p-value, let's just lay down the rules. The p-value is there for each test. SPSS gives you this p-value. The p-value is there so that you can determine whether or not to go with H0 or H1. Okay? Now, the rule is this. If the p-value is low, we reject the null. What do I mean by low? If you're able to reject the null at the 1%,
Rowena says it's actually two-tailed, so you put the applet shaded to the left and the right. That would make sense. If it loads,
whereas if you're able to reject it,
literally just waiting on it for it to load.
that's not 5, so we can definitely go. So,
But my Wi-Fi hates me.
so the null hypothesis must.
I still don't get it, guys. Okay, so. Oh.
Oh my goodness, it's still loading. Email the teacher about what, Rowena?
About the p-value,
Okay, yeah.
if you want to. How to find the p-value. Well, it says you have to use the p-value as given in software as 1.2723e minus 0.08. I don't know what that is. It's in our lesson or text, page 11, this lesson 11.
Okay.
Okay, guys, I found this link, and it has what I think Rowena suggested about the normal probability applet with the two-tailed test. Oh my gosh. I don't know.
I don't either. I'm gonna look. So, there's that one.
My stuff isn't loading, and I don't know why. So, oh.
Okay. The sample mean is the test statistic, right? That's the same thing?
I think so. Rowena says she has an idea, but she needs a few minutes.
Yeah.
Oh, now it's loading. It's loading. Okay.
Question 6. How does the margin of error of 95% confidence interval compare to the 99%? So the margin of error for the confidence interval is going to be smaller for the 95%, and it's going to be bigger for the 99%.
Okay, so I put the thing into the normal probability applet, and it says 0.9061 for the area. And that seems legit. And I shaded the left side and the right side.
So, is that supposed to then be the answer? Or?
Yeah.
So the p-value is also the area. That's the same thing.
And the alternative is that it's
Maybe. Maybe not. Well, then let me pull up the answer key for this.
Oh, that's
for the lesson.
he says can be the test statistic. First compare it
Okay.
Yay! Sorry. That's right.
It's right.
Yes, you're a genius.
It says in the prep assignment, it says the answer is 0.9077.
What happened?
In the answer sheet, the answer key, the answer is 0.09 or 0.9077.
Which
and the answer that I got on the normal probability applet was like 0.9061 or something like that.
Which doesn't make sense, actually.
Why does not this make sense?
Why?
Yeah.
Because if you round 0.9061, you don't get 0.9077.
No.
But it's pretty close.
So you put
That's how I do math. I'm like, it's close. Rowena, do you have any ideas? Still trying. Alright, maybe we can move on while she's doing that one.
I don't think we can because it depends on.
Well, it says this one's just state your decision. Oh, Maybe it is. Do you reject the null hypothesis or fail to reject it at 0.05? So it does require the p-value. But we were pretty close with the 0.961, so we'd still have the same answer.
I agree.
I think it's going to be close to 0.
But we need to know the right way to do it.
Unfortunately, right?
Okay.
Rowena says we should just keep going. So we got 0.9061, which is greater than 0.05.
Yes.
Which means
Failure to reject.
Fail to reject. I agree.
What now?
So for F, we got fail to reject because 0.096 or 906 is greater than 0.05. And so you fail to reject the null hypothesis.
Okay.
Which means insufficient evidence that the null hypothesis.
Yeah, so, going on to G, it says present your conclusion in an English sentence relating the result to the context of the problem. So like Shelby said, we have insufficient evidence to conclude that the age is different than the rest of the average.
National average.
Who buy second homes and are rich and stuff.
So conclude that the ages differ from the national average?
Yes.
Okay.
Do you guys...
I know how to do number, do E.
Do you guys want to wait till he emails us back to do the quiz?
Why don't we do lesson 10 and then wait on 11? Can we do that?
Let's go to lesson 10 and do the quiz on that. That'd be great. Lesson 10. Are we ready?
Yes.
Start. I participated.
You find the margin of error.
These are different questions.
Yeah, it is. This is lesson 10.
Bummer. Okay.
Wait a minute, let me see.
Do you guys mind if I stop the broadcast? I'm going to have to leave here in about 10 minutes.
Yeah, you can stop it and then we'll do what we can.
Okay.